Hello, my name is Jose Sanchez, and I'm talking to you here from the National High Magnetic Field Laboratory. And today we're going to talk a little bit about atmospheric pressure and its effect on objects.
Scientists have come up with lots of ways to measure air pressure, including a unit called atmosphere. 1 atmosphere is the pressure experienced here on Earth at sea level. That pressure comes from the miles of air molecules pressing down, thanks to gravity, on any given spot on the planet's surface. 1 atmosphere is equal to about 15 pounds per square inch, or 760 millimeters of mercury. That's the unit of measure used by our bell jar.
We have here a vacuum bell jar. With this little pump, you can actually reduce the atmospheric pressure. We've connected this hose to the vacuum plate, and there's a hole on the bottom of it where the air gets pulled out from.
First, we'll use a regular party balloon to illustrate the effects of atmospheric pressure. A vacuum pump regulates the air pressure inside the bell jar.
And as you can see, when I turn the pump on, the balloon begins to expand. This is happening because at normal atmospheric pressure, the forces inside the balloon and the forces outside the balloon are equal. So the net force acting on the balloon is 0. When I reduce the atmospheric pressure on the outside of the balloon using the bell jar, I have essentially made the forces outside the balloon less than the forces inside the balloon. This causes the balloon to expand.
Because the force, or atmospheric pressure, is greater inside the balloon than in the rest of the bell jar, the air molecules inside the balloon push outward. They don't stop pushing until the density of air molecules inside the balloon equals the density outside in the rest of the bell jar. The balloon stops growing when that equilibrium is reached.
As you can see here, the red reading on the outside is how much you've reduced the atmospheric pressure by. Inside this bell jar, there is probably about 120 to 140 millimeters of mercury of pressure, which is significantly less than the atmospheric pressure. And that's why the balloon gets so huge. Once I start to increase the pressure inside the bell jar again by turning this valve, you can hear the air seeping back in. The balloon starts to go back to its original shape because I am now creating an environment inside the bell jar which will ultimately reach 1 atmosphere of pressure again, or 760 millimeters of mercury, taking the balloon back to its original size and shape. Okay, so what we have here, just to make things a little bit more fun, is a marshmallow peep. Marshmallow is just a mixture of gelatin, corn syrup, sugar, and there's also mostly air inside marshmallows. So when you put the peep inside the vacuum bell jar, you reduce the atmospheric pressure. Those air pockets also begin to expand, similar to the balloon you saw. It's not as dramatic, but it does expand, and you can see that when I release the vacuum and the pressure goes back to 1 atmosphere again, the peep obtains its original size again. And then after you're done, you can eat your experiment. Yummy.